Working through day 47's Review Bell Ringer to go over so you know what you're doing wrong or what you're doing right, so we can confidently be ready for those EOC style questions. So the first one, a student has a rectangular postcard. So you want to think about a rectangle, and he folds it in half lengthwise. So if this is my postcard, if he folds it in half lengthwise, that means he's going to fold it in half here. And then he rotates it continuously about that folded edge. That means he's rotating it along this line. And it's going to be doing one of these. Hopefully you watched some of the videos that made it a little easier to see those three-dimensional changes. If you didn't watch them, most students have a hard time visualizing this without seeing it. So I would go back and watch those for sure, because these rotational questions will probably be on there, at least one. And if you memorize your volume formulas, there should be one that you should have in the bag. So it should be a cylinder. So we have a cylinder. As far as your rotations are concerned, there's not going to be a lot of these square base shapes that it can turn into. And I don't want to say hard no, but off the top of my head, it can't, because it's turning. And then this would be a triangle, like a right triangle, maybe, that rotated along its height. So along this line and turned this way. Or, the other way, right or left, no matter, but around its height. It would be a right triangle if we were talking about a flat shape that could make a cone. All right, so given the zeros of a polynomial as -2 and 2/3, find the polynomial and then match the correct variable with the correct number. Some big call outs just to make sure we notice the plus and the minus here. But if we have -2 equals x and we have 2/3 equals x, to be able to write the polynomial, we have to find the factor. So the binomial with these two. So we're trying to get it set equal to 0. So we're going to add 2 to both sides for this one. And that's going to give me 0 equals x plus 2, which means this is our first factor. And then with the 2/3, I can't say it enough, you cannot have fractions in the factors. So that's not an option. So we have to figure out how to get it non-fraction looking. So x, so it's going to be 3x. Again, I still want to be equal to 0, so I'm going to subtract 2 from both sides. And that's going to give me 3x minus 2. So my two factors are x plus 2 and 3x minus 2. The easiest way is to now multiply these two together. And you can use box method, or you could use FOIL, whatever works best for you. So 3x times x gives me 3x squared, because remember there's like an imaginary 1 right here. And sometimes it's helpful to write that, not that you don't know, but just to keep you straight. So that's a -2 times 1, which is going to be -2, and then your x carries down. 3 times 2 is 6, and I have an x, so that's a plain x there. And -2 times a +2 is going to be a -4. So that's going to be 3x squared plus 4x minus 4. That is the polynomial with a 0 of -2 and a 0 of 2/3. Now, this is an EOC release style question. It's just rewritten and typed out differently. So 3x squared plus 4x, and I have minus 4. So A in this case is 3. B in this case is a +4, because I have a plus and a plus. So C in this case is a +4, because that minus is in both places. So 3, 4, 4, A, B, C. And it is the same things you've been doing as far as finding your factors, multiply them together, find the polynomial. They just ask it in a really crazy way. True or false, you can have one imaginary solution. That is definitely false. Imaginaries are always in pairs. And that has to do with that negative and the positive. So anytime there's imaginary, it has to be in sets of 2. So there can be 1 pair, so 2, 2 pairs, so 4, things of that nature. Now, number 4, it probably rocked your world, but the reality is this is old school math and you did it a long time ago, but this is really basic, and this has been on the EOC as well, and you already have the skill set to do it. It's just been so long you probably forgot. Most importantly, though, we want to make sure we read. So it says use 3.14 for pi and round to the nearest hundredth, so that's 2 decimal places. So for the first one, we're going to find, this is just like when we were cutting out in our compound three-dimensional figures, but instead it's just flat. So we're just taking the bottom of a cylinder. So I want to find the area of the entire circle, so the whole thing. And that means my radius from center to edge is that 5 plus 3. So that means it's 8. we're going to use pi as 3.14. So pi radius squared is going to be the whole circle. So that would be your whole like shaded circle before they cut the center out. And so 3.14 times 64, it's going to give you 200.96. And we're not rounding this to a whole number because it says to leave the decimals. Now we're going to cut out the smaller circle, which has a radius of 5. Just this part is cut out. So we're just finding the donut. So we're going to find its area. Ooh, that is 3.14, not 41. Sorry, guys. I'm not going to go away. And we're going to multiply it by the radius squared because that is the area of a circle. So that's 3.14 times 25. 78.5. Now what they did was cut that circle out. So then we are going to take those two numbers and subtract them. We're leaving our decimals because that's what it told us to do, because it said we're working in hundredths when applicable. So that means if they're there, we're using them. So 200.96 minus 78.5, and our answer should be 122.46. And this would be centimeters, and a centimeter squared because it's two-dimensional area. It's flat. So again, volume is cubed because it's 3D. 2D is going to be squared. Again, this is really old stuff. Maybe the first day it might have brought back some when we did the areas of flat shapes because of the bases of prisms. But very feasible question. Just a big reminder on how to do it as necessary. All right, this one. A few of you I talked to. It rocked your world. Look, the rectangular prisms. Too easy for volume. Too easy. The whole thing is fairly easy. You have to read closely because that's the only way they're going to get you. Because rectangular prisms are length times width times height for volume. You know, the bottom is a square, so it's length times width. So as far as the computations and formulas, they're probably the easiest there, so they're coming for you somewhere else. So first of all, the area of the base has to be between 400 and 1,000. So I'm going to find the area of the base, which is 25 times 20, which is 500. So area is 500. We already know that that does not reach, like that won't work. That one does not work for the area for the bottom. So then I'm going to do 20 times 60 for the area of that second one, which gives me 1,200, which does not meet, 500, I'm telling you a story. 500 does meet. Oh, I was wondering what I was doing here. 500 is good, so we're going to leave 500 as a thing. So disregard my pink X. 1,200 is too big, though. Larger than 1,000. So 500 is good. So we're still looking at design 1 is still in the game. And then 20 times 30, which is going to be that 600 for area of the base. And that is between 400 and 1,000 as well. So right now we're really focused on design 1 and design 3. We're going to find the volume of these two. So we're going to take that 500 and we're going to multiply it by 10. So design 1 volume is 25 times 20 times 10, or like I said, 500 times 10, which is going to be 5,000. And then design 3 is going to, the volume is going to be 20 times 30 times 15, or 600 times 15, which is going to be 9,000. Now, it said at the top, slide down, it has to hold 40,000 gallons of water. Even the first time I did it, I was like, oh man, what did I do wrong? 5,000, 9,000, not even close to 4,000, because I made the same mistake you're going to make. You're reading this, you see this number, you don't read the whole sentence. The pond must be able to store at least 40,000 gallons of water. These are feet, guys. So this is not gallons, these are feet. So then it tells you 1 cubic foot is equal to 7.48. So for every cubic foot, I can hold 7.48 gallons. So I'm going to take these two numbers. I'm going to take that 5,000. I'm going to multiply it by 7.48. I'm going to take that 9,000 and multiply it by 7.48. 5,000 times 7.48 gives me 37,400, which is not the 40,000 we need. And then 9,000 times 7.48 gives us the 67,320, which does hold the 40,000 gallons of water that we need. So the answer is B. The answer is B. All right, guys, hopefully that ironed out any questions. If you have more, please reach out. I'm here to help. I want to help. Have a great day, guys.